Imagine looking into the depths of space through the eyes of the most powerful telescope ever built. There lies something we once thought was just a failed star, a celestial body that doesn't shine in visible light. But recently, the James Webb Space Telescope has detected something extraordinary, a hidden glow, invisible to the naked eye. These objects, called brown dwarfs, are strange bodies. They're often labeled failed stars because, unlike our Sun, they lack the mass needed to start hydrogen fusion. Fusion, the process that powers stars, requires immense pressure and heat. Brown dwarfs don't have enough mass to achieve this. Yet, despite this, brown dwarfs aren't completely dark. In fact, thanks to the infrared capabilities of the James Webb Telescope, they're revealing new secrets. You see, unlike Hubble or other telescopes, the James Webb operates in the infrared spectrum, capturing light that our eyes cannot detect. Infrared light reveals things hidden in the shadows of the cosmos, objects too cold or faint to emit visible light. When the Webb pointed its sensors at a particular brown dwarf over 40 light-years away, it didn't find complete darkness. This particular brown dwarf, known as WISE 1935, displayed something entirely unexpected. An aurora, much like the northern lights we see on Earth. But how could a brown dwarf, without a nearby star to reflect light from, emit such a glow? Some scientists believed it might be reflecting light from nearby stars. But Webb's readings told a different story. It detected methane emissions, suggesting that charged particles in WISE 1935's atmosphere might be heating it from within. So where do these charged particles come from? One theory suggests an interaction between interstellar plasma and WISE 1935. Interstellar plasma, particles floating through space, could be colliding with the brown dwarf, triggering the auroras we're now detecting. If WISE 1935 is passing through a dense plasma field, this could create a glowing aura detectable by Webb. Another exciting possibility is that WISE 1935 may not be alone. It could have a companion, possibly an active moon or small celestial body. Charged particles from this object might be interacting with the brown dwarf, creating the stunning aurora Webb has observed. To understand brown dwarfs, let's go back to the basics. They are often classified as substellar objects, which means they fall somewhere between the largest gas giants and the smallest stars. Brown dwarfs form just like stars, from the collapse of gas and dust clouds in space. But unlike stars, they don't reach the mass needed to ignite nuclear fusion. To put it into perspective, brown dwarfs are usually 13 to 80 times the mass of Jupiter, our solar system's giant. While that's incredibly massive by our standards, it's not enough to ignite the continuous fusion that makes stars shine brightly for billions of years. Instead, after a brief phase where they burn deuterium, a rare form of hydrogen, brown dwarfs cool down and gradually fade, becoming dimmer and dimmer. But here's where things get interesting. Despite their inability to shine like regular stars, brown dwarfs still emit a mysterious glow. Thanks to the James Webb Telescope's infrared technology, we're able to capture this faint light for the first time. Infrared light waves allow us to see objects that were previously invisible to telescopes that operate in the visible light spectrum, like Hubble. In fact, this glow coming from WISE 1935 is not just a simple reflection, it's evidence of a phenomenon we're still trying to fully understand. This brings us to an even bigger question. Could there be an entire dark universe out there, filled with unseen energies and objects? We've all heard of dark matter and dark energy, the mysterious forces that make up most of the cosmos but are invisible to the human eye. But what if there's more? What if this dark universe is home to other forms of matter, like brown dwarfs, that exist outside the visible spectrum? Brown dwarfs are sometimes called dark stars, objects that exist just beyond the edge of our visible universe. They may shine dimly in our world, but in another dimension, could they be as bright as the sun? Some scientists speculate that brown dwarfs and similar dark objects could exist in an alternate universe parallel to ours, where they emit light and energy in ways that we can't fully perceive in our own dimension. To dig deeper into this theory, we have to look at the very building blocks of reality, quanta. Quanta are the smallest units of energy, light, and matter. They're the particles that make up everything, from stars to atoms to ourselves. And fascinatingly, quanta also include photons, particles of light that carry energy and information across the universe. Even if we can't see it, quanta can exist as invisible light, like the faint emissions from brown dwarfs detected by Webb. This means that, at a fundamental level, Even dark stars are made of light particles, just in a form that we can't usually detect. There's another layer to this mystery, known as Heisenberg's uncertainty principle, which says that on a quantum level, particles can exist in multiple states at once. This principle has led physicists to theorize that there may be more than one dimension, or even multiple realities, hidden within our universe. So, what if brown dwarfs aren't just failed stars, but gateways to these hidden dimensions? If that's true, then every brown dwarf we observe could be a window into a different kind of universe, a dark universe with its own set of rules. Thanks to Webb, we're now closer than ever to understanding what exists beyond our visible universe. Brown dwarfs, once thought to be mere cosmic leftovers, are proving to be much more complex. Could they hold the key to solving mysteries about dark matter, dark energy, and the structure of the cosmos itself? As scientists analyze the data from Webb, they're beginning to see connections between brown dwarfs and other dark phenomena. These findings suggest that our universe may be just one part of a larger, interconnected cosmic structure. Our journey to understand the universe is far from over. With every discovery, from black holes to brown dwarfs, we uncover new layers of mystery that hint at even deeper realities. The James Webb Space Telescope isn't just giving us pictures, it's opening doors to questions we never even thought to ask. If you're as fascinated as we are by these cosmic mysteries, don't forget to subscribe. The universe is